Okay, so in this first one, you're going to determine the flow capacity of the roadway cross-section, and the policy requires the 10-year runoff not overtop the curb, and that the spread not exceed 1/2 the outside driving. So there, you have this given there. The travel lane is 12 feet wide. You have a curb and gutter with a 2-foot wide gutter and a 6-inch high curb. You have a cross slope of 2%, a longitudinal slope of 1%, and then you have as well. So you have to find the allowable spread, the gutter capacity for that spread, and the flow velocity. And if you turn the page, we gave you some equations that might help you with this. And we'll give you a few minutes and then form the answer. So let's just do question 1 right now, and then we'll move to question 2, okay? Okay, why don't we go over the answers or the questions? We'll give you the answers. So, I need my glasses for this. Okay, so question 1, the allowable spread is what? 8 feet. There you go. So 2 feet plus 1/2 times that travel lane, 8 feet. And then at this spread, the depth at the curb will be 0.16 feet. Did everybody get that? Okay. And moving on down. So therefore, yeah, I don't know why they do that. So the street capacity, what did you get for that? 1.31. So what we're using is this equation here, right? And that gives us the street capacity of 1.31. And then the velocity, we use the equation at the top. Who got the velocity? What'd you get? 2 points. It's on this page.
I have a question.
Yeah.
Why are the slopes 0.2 and 0.1? Should they be 0.02 and 0.01?
Yeah, they should be. Yeah, they should be.
It's the right answer.
Yeah. Yep, they should be.
Got there.
Well, I got the wrong answer with that equation.
Like I was telling somebody else, we put these slides together real fast. That's what it should be. So you get a Q of 1.31 CFS. And then what'd you get for your velocity? 2.0 something or other? Yeah, so if you use that equation that was on the other page under remember. So you can use cube continuity equation, or you can use Manning's, and you'll get, this one should be 2.04 is what we got. Okay. So 2 different ways you can do it. And honestly, if I were reporting this out, I'd say that would be 2 feet per second, not 2.0. Yes.
That 0.1 should be 0.01 again, right?
Yes,
Or-
it should. Yes. Thank you. We have some cleaning up to do. Okay, so let's go to the composite section. And this time we're going to determine the flow in the composite section. Everything is pretty much the same except in the gutter cross slope. We now have 8.33% slope. And I think everything else is about the same. So let's see if you can figure this one out. We're going to find the spread again, the capacity for the allowable spread, and the flow velocity for that spread. And again, we gave you some equations you can use that will help you out.
Some baseball salaries. I did it for young kids.
Just give you a couple more minutes and we'll move on. Okay, so let's go over these answers or questions. So our allowable spread this time is what? 8 feet, yeah. It's the same as before, that hasn't changed. So the depth of the curb will be, what'd you get?
Yeah, that wasn't asked for.
No, it wasn't asked for?
No.
Not even?
No.
No, that's weird. All right, here it is. Oh. Because what you're doing is taking 0.02 times that 6 feet in the street, and then your composite section. So you have to have them together. The depth of the curb now will be 0.29. How did that happen? Okay, there for your T is that, your depth is that. And notice that the curb height is 0.5, so we are not overtopping the curb, right? Okay. So the street capacity at that allowable spread is what? .6. Did everybody get that?
No.
Yeah, 0.61. Yeah. Let me look at the substitutes here.
Those are slopes are correct.
Yay. Yeah, so do you understand what we're doing here? As I was saying over here, we want to find out what was just happening here. And so that is our QS. We put QS sub S into that equation and we find 0.61 feet, cubic feet per second. Okay, and so you can use the equation if you're really ambitious, or you can just use the chart and tell me what your gutter flow ratio was. 0.6, well, yeah, your WT was 0.25, your T over W is 4. That SW over SX is 417, and so you come up, we came up with 0.69. If you're close to that, that's fine. Some people got 0.75 or 0.7 or something like that. So the total capacity, street and gutter, is then, we're using this equation, right? So what'd you get? Did you get that? 1.97?
Off by 600, so CFS.
One did. So I would have just said 2. Yeah. And what about the velocity? So if you want to do V equals Q over A, you have to find your A, your area. Oops. First you have to find it up here. So that's your equation, and come up with 0.77 square feet. Everybody get that?
Yeah.
No.
Oh, I got that.
I see what it is.
Oh, for this. Okay, and then for your velocity, it's just the Q divided by area. Discharge divided by area, and you get 2.56 feet per second. Total Q. Total Q. It was that Q equals Q street capacity divided by 1 minus E sub this. And you had wasn't that 2.56? No, it was 0.61, sorry. Okay.
But still, it's
Your gutter flow ratio, which was the E sub O. What do you get for that? What do we get for that? Wasn't that the 0.69?
So that's total, that's not.
We took that from the chart. You can figure it out from the equation as well.
Oh, I'm dyslexic.
No, that's the ratio.
Any other questions? So now you all can do this in your sleep, and more than likely you'll use a program instead. Okay, why don't we take how about we take, well, come back at 2:30. But you know what I didn't do? I didn't do the learning objectives. Let's go through that really quick. So list the variables that affect flow in gutters. Can you do that? Cross slope, longitudinal slope. No, that doesn't affect it so much. Gutters, cross slope, how about the flow in the gutter? What are some of the others? What's the width of your gutter? The gutter flow ratio? Yeah. Yeah, we said that longitudinal slope, cross slope, grade width, the gutter flow ratio, your frontal flow, yeah, all of that. Okay. Can you demonstrate, well, did we demonstrate advantages and disadvantages of a gutter, composite gutter section? I don't know that we talked about any disadvantages. To me, there aren't too many. What is an advantage? Increased capacity, so you get increased flow. Yeah, because we could demonstrate that we got about 25% more flow in the gutter using composite than using a uniform sill. And we applied the gutter flow ratio concept, and it helped us find the total discharge when we knew the street capacity discharge. So we did that, and we calculated the flow capacity of a gutter section, both uniform and composite. Okay, now 2:30.